Hello friends, welcome to Kranthi's tutorial, Kranthi's Physics Tutorial. Okay, so today in this class we have to discuss about the Newton laws. So very important. So in your first year physics, so you have the Newton laws. You have the Newton laws in laws of motion topic. Okay, so Newton laws is the most important, one of the most important questions in your first year intermediate textbook. Okay, so Newton laws. So Newton laws are in which topic? Newton laws are there in which topic? Laws of motion topic. So first, Newton stated three laws. Newton stated how many laws? Three laws. Newton stated three laws. So we can discuss about those three laws one by one here. Okay. So first of all, Newton's first law. Newton's first law. Newton's first law. Newton's first law. So before going to discuss about the Newton's first law, first of all we have to study about the inertia. So what is the inertia? We have to study about the inertia. We have to study about the inertia. So inertia. So first of all we discuss about the inertia, then we will go to the first law. So why? Because the inertia property can be taken as the first law by Newton. So Newton so stated the first law. So by taken the inertia definition. Inertia definition can be taken as stated as his first law. So that's why we have to discuss about the inertia property. So what is the inertia property? So every body in the universe, so every object in the universe, every object or every body in the universe, so the body or object in the universe, or if the body or the object is at rest position, it is always try to be at rest. If any body it is in motion, it is always try to be in motion. So that property of the body is called as the inertia property. Inertia property. So in any body in the universe, if that body, if it is at rest position, the present state of the body is rest, then it is always try to be in that state only. It is always try to be at rest state only. If any body is in motion, it is always try to be in that state only. That body is always try to be motion only. So that property of the body is called as inertia. So here, what is the inertia? Inertia is the property of the body. Inertia is the property of the body. So what is the meaning of the property? That property, if any body is in rest position, it is always try to be at rest position. If any body is in the motion, it is always try to be in motion. So that is the property of that property of the body is called as the inertia. So inertia means, so what is the meaning of the inertia is, inertia means resistance to change. Resistance to change the state. Resistance to change the state. Inertia means resistance to change the state. So every body is always resist the change of its present state. Every body in the universe is always resist to change the state of its present state. So the rest body, if a body is at rest position, it is always resist to change the, it will convert into the motion. If a body is in motion, it is always resist to, it is converted to the rest position. So that's why inertia means here resistance to change the present state of that body. So this inertia property, and here also you can remember one important point. So that is, what is the measure of inertia? what is the measure of inertia? So mass is the measure, mass is the measure of inertia. This is also one of the important point. So what gives the measure of inertia? If we measure the inertia, then it will gives which one, what one? So that is called, so the inertia gives us the mass of a body, So here, so what we can say, that the mass is the measure of inertia. So this is also one of the most important point. So inertia, here you can remember three very important points. So first is the, what is the definition of the property of inertia? So if a body is at rest position, it is always try to be at rest. If a body is in motion, it is always try to be in motion. That is the first point. That is the definition of the inertia. And the inertia means, what is the meaning of inertia? Is resistance to change the present state. So that is the meaning of inertia. You can also remember this point. And the last one is the, so what gives the measure of inertia? If we measure the inertia, it will give which property? That is mass. Mass is the measure of inertia. You can remember these 3 points. So here, this inertia property can be taken as his first law. So who is that one person? Newton. So Newton can be taken as the inertia definition as its first law. So here I can write the Newton's first law. So that is if a body is at rest, it is always try to be at rest. If a body is at rest, it is always try to be at rest. If it is in motion, it is always try to be in motion. If a body is in motion, it is always try to be in motion. So this is the, this property of a body is called as, so which one? What one? Inertia. So Newton just add some word to this definition, inertia definition. So that is, so if a body is at rest, it is always try to be at rest. If a body is in motion, it is always try to be in motion, unless an external force is acting on that body. So unless an external force is acts on the body, acts on it or acts on that body. So the up to how much time the body resists to change its motion, unless an external force is acting on the body. If the external force is acting on the body, then it will be converted into the motion. The state will be converted easily from motion to rest or rest to motion. But unless an external force is acting on the body, every body in the universe is always try to be, if it is at rest, it is always try to be at rest. If it is in motion, it is always try to be in motion. Just Newton add just this word to the inertia property. Inertia property can be taken as his first law, Newton. So just for this definition of the inertia property, Newton added this line. So what is that? Unless an external force is acting on the body. So up to if there is no external forces acting on the body, it is always try to be resist the change of its state. But once the force is acting on the body, it will be easily converted into the one state to another state. So that is the Newton's first law statement. Okay, is it clear? So Newton's first law statement is from where it will becomes? From the inertia definition. Okay, so now we have to discuss about the Newton's second law. Okay, so Newton's second law. So here first law is clear. Now we have to discuss about the Newton's second law. So Newton's second law. Newton's second. So Newton's second law is the very important law. Newton's second law is the very important law. So what is the Newton's second law? So the rate of change of momentum of a body. So listen carefully the statement of the Newton's second law. So the rate of change of momentum of a body, the rate of change of momentum, the rate of change of momentum of a body is directly proportional to the rate of change of momentum of a body is directly proportional to the force acts on the body. So this is the Newton's second law statement. Very simple. So the rate of change of momentum of any body is always directly proportional to. So the force acts on that body. So here you must and should remember rate. So wherever you get the term rate, so rate means with respect to time. So the rate of change of momentum can be denoted by the letter P, momentum. So the rate means with respect to time. So dP by dt. So here is directly proportional to the force acting on the body. So dP by F is directly proportional to the dP by dt. So here P is the momentum. So rate means with respect to time. So the change of momentum with respect to time of any body is directly proportional to the force acting on that body. So how much force is acting? So that is proportionality to the rate of change of momentum of in that body. So that is called Newton's second law statement. So F is directly proportional to dP by dt. So now from this equation we can prove that F equal to ma. So now from this statement, from this second law, so Newton proved that F equal to ma. So until the Newton stated proves this law F equal to ma, so until everybody thought like that the force and mass both are different quantities. But the Newton, according to the Newton second law, Newton proved that there is a relation between the force and the mass of a body. So thus equation is F equal to ma. So here from this second law, in this second law we have to prove that F equal to ma. So proof. So for example, if a body is there, any object is there, so this object has the mass m, and it will be moved with some velocity v. So when the body is in motion, definitely some force will be acting on the body, then only the body is in motion. So that's why here some force F is acting in this body. So we consider a body of mass m and some force F is acting on that body, then the body moves with some velocity v. So then according to the Newton's second law, we can write F is directly proportional to the so dP by dt. So the rate of change of momentum of a body, the rate of change of momentum of a body is directly proportional to the force acting on the body. So but we knew that momentum P equal to product of mass into velocity mv. So momentum is what? So momentum means mass of the body and velocity of the body. So we can product them combinedly. Then we get momentum. So momentum P equal to product of mass and velocity of the body. So that's why P equal to mv. So we can write in place of P, we can write mv. So F is directly proportional to dmv by dt. But mass is the constant value. Mass cannot be changes for any body. If the force is acting on the body, only velocity will be changes. The change in velocity is occurred only, but mass does not changes. That's why mass is constant value. That's why we can't differentiate the mass term. We can differentiate only the velocity term. So F is directly proportional to m into dv by dt. M into dv by dt. So we can get it out the mass term. Only we can differentiate velocity. Why? Because the velocity will be changes. The velocity will be changes with respect to time, but not the mass. So that's why we can differentiate only velocity. But the rate of change here dv by dt means the rate of change of velocity. So the velocity changes with respect to time. Velocity changes with respect to time. What we call it as acceleration. So that's why F is directly proportional to ma. In place of dv by dt means velocity changes with respect to time, means that is called acceleration. So in place of dv by dt we can write the acceleration here. So F is directly proportional to ma. So F equal to, here proportionality constant k, we get proportionality constant k to ma. If k is 1 unit, so the proportionality constant is 1 unit, then we get m. So this is the famous relation, stated by the, derived by the Newton. What is that? F equal to ma. So finally Newton stated his second law, and according to the second law, Newton derived the famous relation between the force and mass, that is F equal to ma. So hence we proved. Hence we proved the relation F equal to ma. So here F is the mass of the body. F is the force acting on the body. M is the mass of the body. A is the acceleration of that body. Acceleration means what? Change in velocity with respect to time. Okay. So this is about Newton's second law and its a derivation part. Is it clear, everybody? Is it clear? Okay, thank you. Now we will go to the last law, that is Newton's third law. Okay, Newton's third law. Newton's third law. So Newton's third. So what is the Newton's third law? Very simple. For every action, there is equal and opposite reaction. So for every action there is equal and opposite reaction is there. So that is called Newton's third law. So for every action there is equal and opposite reaction. So for example, if a ball, so we can throw the ball to the wall. So some force is, then what happened? The ball acts some force on the wall. So at the same time, that is the action force. So at the same time, the counter force is acting on the ball by the wall. So first, just very simple example. So we can throw a ball to the wall. Then what happened? So the force is acts on the wall by the ball. This is the action. At the same time, so after the action force is acting on the wall, then the wall applies the reaction force on the ball. So the first action force is acting on the wall by the ball. The second reaction force is acting on the ball by the wall. So that is called the Newton's third law. So if there is any action force is there, definitely there is must and should be reaction force is also applied. So that is called Newton's third law. So if action force is there, definitely reaction force is acting on the ball. But here the action force is acts on the wall by the ball, but the reaction force is acts on the ball by the wall. That means here the action and reaction forces are not acting on a single body. The action force is acting on the wall, the reaction force is acting on the ball. So that's why the action and reaction forces are acting on the two different bodies. Here where where the action and reaction forces are acting on two different two different bodies not on a single body. The action reaction force is not acting on a single body. The action reaction force are acting on two different bodies. So that's why, so here we can write the statement, we can write the equation for the Newton's third law. So FAB is equal to minus FBA. FAB is equal to minus FBA. So here if FAB means the force acting on the body B by A. Here the force acting on the body B by A. So the force acting on the body A by B. Here the force acting on the body B by A. So the force acting on the body A by B is equal to the force acting on the body B by A. But both are in opposite direction. Both are in reverse direction. So that's why here we can take the negative sign. So negative sign means the reaction force is acting in the reverse to the action force. That's why here we can put the symbol negative symbol. So this is about Newton's third law. Okay. So this is about the total Newton's laws. So how many laws are there? Newton stated three laws about the motion. So first law, second law and third law. All these three laws are very very important. Among all these three laws, the second law is most important. The second law is very very important. F equal to ma. F is directly proportional to dp by dt, and from that we can prove that F equal to ma. That is very very important. So is it clear? So I think everybody clear about Newton laws. Okay, is it clear? Thank you very much. Okay.